Раз. Hello students, this lecture will be on statistical differences criteria. So when you try to prove some hypothesis and make some samples or some calculations, you should know what criteria you will use or not use in your survey. So I'll give you classification, recommendation. We have some examples on parameter criteria such as students or Fisher criteria. So if you have hypothesis test parametric, and you have worked with values and your data normally distributed, you can use usual Pearson correlation and so on. And if not, then you use Mann-Whitney test or Spearman correlation and others, of course. In your survey, you will face with situations where you have independent samples and dependent samples. So if values in one sample affect the values in other sample, then you have dependent sample, like if you in medicine survey and you give some drugs to your group of people before and after, then you can use dependent. And if there are two groups when there is no effect, so then use independent values. Test. So this is table that help you to understand some parameters and test classification, and if you look at it, you can use it in your survey and choose your best test methods, parameters or not parameters. So let's have an example, and as usual we use students t-distribution, and this example will have this confidence level of 95% that give us 5% of alpha and its significance level. Then the mean of our sample is 165, and standard deviation of this sample for 0.5, and we have the values of our sample number is 20. As you can see, that 20 is less than 30 that we use when we calculate the criteria before. So, and we don't know the standard deviation of whole population, refers as sigma, and now we use S. So we go to student distribution. In student distribution, we have such parameters as mean by sample and the margins or boundaries of this mean that we calculate on some level of confidence. And we use V parameter, its freedom degree. As you see, it's the size of your sample minus 1. In this sample we have size of 20, and minus 1, it will be 19. So if we use some sketching, It will be like that. So it's our standard deviation. We have the mean here. And this is our margins or bounds. So if we have level of confidence in 95%, so this is of our sample, we'll place there. And this is the boundaries that's not will have in our. So it's if we divide alpha by 2, so we have this will be our parameters for calculation T criteria. This T criteria later. And then we go to this. It's the same. So we have plus and so we have minus. So we go to our table. It's standard table of T distribution. So we have our freedom, value of size of our sample minus 1, it will be 9. Then we have our sorry, it will not be 9, it will be 19. Then level of our confidence and T distribution, as you see, it will be 1.5, it will be here. So it's a two-tail area. And we use this. Then we calculate this value here. We put it like that. And it will be our S. And this is N. This is T parameter. So we have error bound for mean. It's 2 and 106. So if we place here, so we have 0 our mean, and here we have our two boundaries. That with level confidence I get to this result. This is one example of T distribution or student distribution. Then we have another one. In this example, you have some survey and you get some marks of the students, and you have to construct a 90% confidence interval of your mean and calculate your error or margin error boundaries. So, how to calculate it? First of all, you calculate the size of your sample. It will be easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the size of your sample is 10. Then calculate error bound for mean. So first we calculate the mean of the sample. So it will sum all of and divide by our n. So it will be 80. Then you have to calculate your deviation by this formula. So you go like that. It will be sum of plus and so on. And of course, divided by your size minus 1. So after this calculation, it will be 11.709. Then we calculate T criteria. Of course, we're using the standard table as in previous example. So let's go. It will be 90% confidence level, and our n will be, and v will be -1, will be 9. So we use the same calculation level and we use it like that. It will be here sorry. Levels of freedom. 9. Confidence level. E. And here we go. And we get here this parameter that we place in our formula. So here we place this parameter. And then calculate our EBM. So place here our T criteria, then we multiply by our mean sample and divide by our size of our sample. So, and we get interval here, and we use it, so it will be like that. This is our mean, and then we have here and here we have so we have $86.787. So I think after these two examples, you could calculate your IBM in your survey. Just simple. See you later on next lecture. Students t-test is used as well when we compare independent samples. So if there are any difference between them, so these are the steps, and we define null and alternative hypothesis about is there any differences or no differences. Then we state alpha this is a level of significance and calculate degrees of freedom. It's the size of our samples -2 as usual. Then state decision rule when we reject null hypothesis or we can't reject and we accept it. And then we calculate test statistic, state result, and state our conclusion about it. So this is formula for calculating our t-test on independent samples, and as well as you see in denominator of square, whereas n1 plus n2 minus 1 is the same thing as the n plus m minus 2. So let's go to the example. This is our formula, previously placed on slide. And then let's have this example, like there are two different education methods that apply to different groups of students. And does any difference exist between these two methods on significance level? P or alpha is 0.01. So it's 1% of our mistake if we take our null hypothesis. So these are the test of marks that was gotten by students. So we made some calculations before. I will not waste time on it now. We have mean of the first group, mean of the second, then standard deviation and the degrees of freedom. As you can see, there are two groups of 10 persons, and we make it like that: 10 plus 10 minus 2, and it 18. Then our t is 0.46, as you see. Then we go to the students' distribution table and we take our parameter, as you see here. So the degrees of freedom is 18. So we have this. And we go as far as our alpha or level of significance. It will be so on it. This was level of significance. Intersection. We get this value and we place here. So if we made our standard probability distribution, here will be this way to tell and FTR, fail to reject. Then we have our t-sort chase 2, and we see that there is no difference because we have it like that. Here on this. See, there is no difference between two methods of education that was applied to our two groups of students. Sometimes in statistics, when we want to see if any difference between two groups, we used Fisher's criteria based on a correlation or dividing of a standard deviation of these two samples. So, as you see, we calculate by first step the square deviation or dispersion, as you can see, and then we put the major value on numerator and the lesser on denominator. So this is, as you can see, here it will be lesser and this is more. Yes. In this way. Or if we calculate and see that the second is larger, then we place the second here in this place. Let's imagine that we have two groups of people with some marks or some other parameters, and we want to understand if there are any difference between them. So we calculate our standard deviation or square deviation and we divide one on another. Then we have to place some level of significance. It's like alpha. It will be like that. And we calculate these two criteria and get the standard value of this from table. So we have two groups by 10, and so we have the degrees of freedom will be degrees of freedom. It will be from one group, it will be size of sample minus 1, and from another it will be the same. So on this table we have one denominator and numerator. And on intersection of this, we get this value and we place here. So, as we can see, that this value is less than our value if we make sketch and see this area, and this value will be here, the standard for this. And our value is here. So we reject our hypothesis of that there is no difference between two samples, and we make conclusion that there are differences between them. So difference exists by Fisher criteria with such a level of significance. This is here as a level of significance. Now the lesson is over. See you next time.